Okay, so we'll go ahead and get our meeting kicked off today. My name is Jacob Bleacher. I'm the Chief Exploration Scientist in the Exploration Systems Development Mission Directorate. And I'd like to welcome you to our 19th virtual session of the Lunar Surface Science Workshop. This one is entitled Integrating Science into Artemis. So the Lunar Surface Science Workshop was originally planned as an in-person meeting that was to be held in late April in 2020. We, at that time, decided to move to a virtual format and have held one every month to every few months over the last several years. LSSWs, Lunar Surface Science Workshops, are typically focused on a specific topic to encourage community discussion and usually are followed by a development of a report that serves as a referenceable document for NASA and others as we develop our plans to explore the moon. Once per year, we provide an update from headquarters, and that's what we're here to do today in the virtual session 19. This is our first Lunar Surface Science Workshop with a completed Artemis mission in the history books, which means that for the first time at a Lunar Surface Science Workshop, we can refer to ourselves all as part of the Artemis generation. So this really is an exciting time. We're going to begin today speaking with Nicky Fox, the Associate Administrator for the Science Mission Directorate, and Jim Free, the Associate Administrator for the Exploration Systems Development Mission Directorate. If you have questions that you'd like to ask Nicky and/or Jim, please put them into the chat window here. And as time permits, the moderator for each session will ask questions of the speakers at that time. So with that, Nicky, I'd like to hand off to you to kick us off.
Thanks so much. I'm really looking forward to hearing the outcomes of the discussion. Obviously, the thing that I care about the most is adding science to Artemis and to the Moon to Mars program, and so it's really great to be able to be with you all today. Oops. All right. So I wanted to start by just giving you sort of a high-level look at the Science Mission Directorate. We have 6 divisions that study the sun, the Earth, the planets and moons, and the rest of the universe, and also how biological and physical processes change in space. So I'm really excited to speak to you today, knowing that all of our divisions can really benefit from these lunar surface opportunities. So we do like to think that science is at the forefront of everyone's minds as the Artemis program unfolds. The phrase "science enables exploration" and "exploration enables science" comes from our Lunar Reconnaissance Orbiter Team, or LRO, and I really think it couldn't be more true than in our current era. The Moon to Mars program will be really successful thanks to the incredibly strong collaboration between SMD, the Science Mission Directorate, and ESDMD, the Exploration Directorate. So we're really enjoying the partnership and looking forward to everything that we can do together. So to sort of illustrate this strong partnership, I'm going to kind of look at some of these objectives a bit more. You can see here all of the objectives for Artemis, and just sort of working backwards, maybe from the last to the first. So we'll break down the 2 parts of the phrase, that science enables exploration and exploration enables science. And so we're focusing on how science really enables exploration here. And objective 7 is all about how science really helps exploration. So 3 of our divisions do research that directly impacts our ability to explore the moon robotically, and then, of course, with humans. In planetary, LRO has provided incredibly high resolution, literally down to a few meters, which are the basis for all of our plans to kind of return to the moon. Our scientists continue to study the lunar surface to identify locations that will maximize all of our Moon to Mars objectives. And I know the last iteration of this workshop in April was focused on science from the 13 potential landing sites for Artemis 3. In heliophysics, coolest, hottest mission, coolest, hottest division, we're looking at how space weather negatively affects our astronauts and how solar systems can be very detrimental to the unprotected human body. Through our missions in heliophysics, we are better able to understand how and when solar phenomena occur. And, very recently, scientists with our Parker Solar Probe mission think they've discovered the processes that give birth to the streams of charged particles that emanate away from the sun and bathe all of the planets, of course, impacting particularly the moon, as the moon orbits around the Earth and spends a lot of time in the pristine solar wind, not, sort of protected by our magnetic field. We also used observations from Parker Solar Probe along with images from the Solar Dynamics Observatory to sort of arrive at these really big conclusions. So finding out how the solar wind is energized, the evidence for small-scale jetting in the sun's corona driven by magnetic reconnection is thought to now be responsible for that heating and acceleration of the solar wind. In BPS, we are enabling exploration in two ways. So that's biological and physical sciences, you see there. We're studying the effects on people. So looking at the effect of lunar regolith looking at the dust. So, we mainly care about permissible exposure limits, how much people can inhale without having extreme reaction. And BPS is studying the long-term consequences and the kind of underlying ramifications. And so, that just also highlights why it's so important to save samples. There's some, new analysis techniques will come out and allow us to do yet more science with those samples, even more than 50 years after they've been taken. They're also looking at radiation from the sun and cosmic rays. Space biology is obviously in SMD and performs research to understand mechanisms of tissue damage and also like aging in space. And so we're beginning to understand all of the components and associated dangers that are part of radiation in space and the effects on the human body. And then finally, learning how to grow plants in space to enable sustained human exploration. BPS recently co-sponsored University of Florida researchers who grew plants in the lunar regolith that was gathered during the Apollo missions. And so this is, this research is definitely part of the Apollo Next Generation Sample Analysis Program, which is, allowing us to continue studying those samples returned from the Apollo program. Sadly, the plants were not as robust as those grown in Earth soil, but they did indeed grow, and we're very proud of that. Now, if we focus on how exploration enables science, all of our divisions will be taking advantage of our return to the moon. And many of these things are explicitly called out in the Artemis Moon to Mars program objectives. Revealing the record of the ancient sun, something I'm personally really excited about, and our astronomical environment. So in heliophysics, we'll use the surface environments kind of as laboratories to understand space weather phenomena and the magnetotail solar wind dynamics and study sort of fundamental plasma processes. And this is science that can only be done with surface missions, looking at how the history of the sun is recorded in the lunar and indeed in the Martian regolith. So objective 5, observing the universe and the local space environment from a unique location. Obviously at Earth, we're exploring ways to use the moon as a new vantage point to allow the Earth Science Division to study the Earth. And in Astro, they're looking at what the far side of the moon can do, offering a radio quiet environment to allow us to make measurements of the radiation from the dark ages and the cosmic microwave background that are normally blocked by the ionosphere on Earth. And then finally, looking at objective 6, conducting experimental science in the lunar environment. BPS, all of the research described that enables, exploration in biological and physical sciences will also benefit from robots and humans on the surface of the moon and beyond. And of course, with planetary science, we have the opportunity to study the moon in many different ways. This is the lunar fleet that we have. So, for decades, NASA science has already been working on some of these objectives, certainly objectives 1, 2, and 3, trying to understand lunar volatiles, the impact history of the moon, and trying to understand just, planetary processes in general. This chart shows our current and future lunar missions. In addition to the Artemis program, we're really excited to be engaging with commercial partners to enable science on the lunar surface. And that's done through our CLIPS program. And we're really excited to have our launches in the coming months of 2 of the 14 approved providers. The first one will be Astrobotic Peregrine 1. And the science objectives of the mission are to study the lunar exosphere, the thermal properties and the hydrogen abundance of the lunar regolith, magnetic fields, and the radiation environment. And they'll also be testing some advanced solar arrays. The second one will be Intuitive Machines, Nova C. And this mission objective is to place Nova C on the crater rim of Malapert A near the south pole of the moon. So it's got 5 NASA payloads on it and some commercial cargo from science. They're looking at studies of plume surface interactions and space weather interactions with the lunar surface. And they're going to be demonstrating precision landing techniques as well as communication capabilities. And then Viper, which is a dedicated CLIPS payload, our volatiles investigating polar exploration rover, or Viper, that is going to be able to explore the relatively nearby but extreme environment of the moon in search of ice and other resources. So really excited to be using all of this fleet to really further and prepare for our sort of sustained presence on the moon. And with that, I will say thank you.
Thank you, Nikki. That was wonderful information to see as we're thinking about the science we want to do while we explore the moon. Next, I'd like to welcome Jim Free, again, the Associate Administrator for the Exploration Systems Development Mission Directorate. Welcome, Jim.
Yeah, thanks, Jake, and good morning, everybody. Thanks for having me here today. I really appreciate the opportunity to speak with you, and certainly to follow Nikki is a daunting task for me. And as Nikki's come on board, we've built on the fantastic work that our mission directorates have already been doing. Jake is our lead for that, and that interface and continues with a number of meetings where we've continued to talk about how we're completely intertwined. Nikki and I just had one, I'm getting lost in my weeks, Nikki, but just last week with Pam, where our deputy administrator has been very clear about the connectivity that she wants us to have. And I was proud to sit there and say, hey, we have that. We're down that path. And Nikki has certainly embraced that as she's come on as the AA. So let's talk for a minute about why we go. And Nikki referenced it, and many of you have seen the Moon to Mars objectives led by our Deputy Administrator, Pam Melroy. And one of the fundamental pillars, and frankly, the one that I talk about a lot is that scientific pillar. And what we learn on the moon is going to enhance our understanding of the solar system, our home planet, and the human body, which is certainly important for us as we look at our missions to the moon and beyond. And under Artemis, we're going for long-term scientific discovery, and I'm excited by everything we'll learn, because everything we learn fuels and science. And Nikki, I think you said it best last week, that every discovery we make, every answer we get leads to new questions. And that's why we're going to the moon long-term. We can't get all the answers we need in one mission. We need that sustained presence. And Artemis is really different than anything humanity has ever done before. It's a long-term effort. We won't go for one mission and never go again. We're going to build a lunar economy. And to that effect, hardware is in development through Artemis 5. I've even seen hardware just within the last couple of weeks through Artemis 7. Metals being cut and welded, systems are being assembled and tested. And as Jake said, right, we're part of the Artemis generation. Those beautiful 3 pictures down the left side of this slide are forever etched in my memory. We have Orion capsules being built and assembled around the world. We have the Space Launch System rockets in production in the U.S. We have hardware for international missions, our international habitation being built in France, and the life support systems for that in Japan. It is truly a hardware-rich program, as I mentioned, with things even out through Artemis 9, and we have contracts through built through Artemis 7. We have contracts through Artemis 9. Truly phenomenal to see that happening. Just last week, we selected Blue Origin to provide the human landing system for Artemis 5, bringing on a second provider in addition to SpaceX. Having two lander providers really offers us robustness and ensures a regular cadence of moon landings, all to do the science that Nicky was highlighting. We've heard how big the deck is on Starship, about the size of a stage, really. And actually, I was out at SpaceX, and they have a simulation of how big that deck is going to be. And imagine the scientific investigations we'll be able to bring to the surface with that kind of volume. We are contract and hardware rich on Artemis, as I mentioned. And not only that, we have incredible partners as well. Partners really create more opportunities for science. Nicky mentioned CLIPS in her remarks. We have international partners as well that are looking to contribute. Building off our longstanding partnerships aboard the International Space Station, a lot of our international partnerships are in lunar orbit. On Gateway from the IHAB that I mentioned earlier, where we conduct science, to the Canadarm3, to the Esprit refueling module, to the HTV-XG resupply logistics spacecraft from Japan. We also have study agreements in place to provide a pressurized rover where the crew can work on the surface in a shirt sleeve environment, surface habitation to enable longer stays to conduct more scientific investigations, a cargo lander that can carry investigations, and a utility rover that has the potential to enable our astronauts to do even more science. I've mentioned a lot of the projects today, all under the Artemis umbrella. Each of these products helps us build a lunar ecosystem. Over time, our missions will increase in complexity because we're bringing new capabilities online. Moreover, our industry partners want to come with us, and we plan to use what we've learned in low Earth orbit to help us out at the moon. We continue to transition low Earth orbit to private industry, so we're one customer of just many. Commercial providers already carry cargo and crew to the space station, and entirely commercial destinations are in development for the end of the decade. And that commercialization offers us opportunity to continue science and research while allowing industry to develop business opportunities like in-space manufacturing, medical research, and technology development. We want the same commercial robustness at the moon to create a future where more people conduct science off this planet and on the lunar surface. Nicky and I are going to take questions here in a moment, but I want to leave you with this thought. Every Artemis mission adds opportunity for science. Every Artemis mission increases our capabilities to do more. We started on Artemis 1 with a great deal of science, from CubeSats to a number of payloads hosted inside Orion. Artemis 2 is going to test our environmental control and life support systems and allow us to study the human body with newer technology as we transcend outside the Van Allen belts. Higher energy radiation exposure is a unique stressor that can affect our ability to sustain life off Earth. It's a big risk. What we learn on Artemis 2 will help us prepare for long duration stays on the moon, where astronauts will be subject to similar radiation environments. Understanding how to protect them is absolutely critical to amplifying our future science return. On Artemis 3, we'll land and go where we haven't been in 50 years. We're planning that science right now under the leadership of Dr. Noah Petro. Dr. Barbara Cohen will lead science for Artemis 4, which will bring Gateway online, a fantastic platform for heliophysics and biological sciences. I'm trying to look at Nicky for her reaction when we talk about that. Big supporter there. We'll land again on Artemis 4 also as we start our yearly cadence. And Artemis 5 adds the lunar terrain vehicle to increase our science radius as well, which we found to be critical on Apollo. We'll bring more surface experiments on Artemis 6 and the pressurized rover on Artemis 7. We'll have all those CLIPS landers that Nicky showed you with the science payload and technology demonstrations throughout this, helping us understand where we're headed with our human program as well. This is the start of a lunar ecosystem and where we'll do more science than we can dream of. The future is coming, and I'm excited really for that scientific reward. And I can tell you that we are completely focused on that also. So thanks so much for your time today. I'll reiterate, we are going, and science is at the forefront of why we're going. So with that, let me turn it back over to Jake.
Thanks, Jim. It's great words. Really appreciate Nicky and Jim, both of you taking some time out of your day to join us here. It's a good opportunity to talk to our community and just kind of relay the excitement you both feel and many of us inside NASA feel to everybody that's looking to NASA, looking to industry as to how we're going to go explore the moon.